Question number 21 says that a wave pulse is propagating a long stretched string along its length, taken as positive x-axis. The wave equation is given by this. Some pulse is moving with y naught is equal to 2 mm and t is 1 and lambda is given 2 centimeter. The velocity of this wave. Now dear student, we have to look into this one. It's given that t divided by t minus x by lambda is basically the phase, and phase should remain constant. If the phase remain constant, that means its derivative with respect to time will give you the velocity 1 upon t minus v by lambda should be equal to 0. If what is velocity? Velocity is lambda divided by t. Now what is lambda given? Lambda is given 2 centimeter. And what is t given? Equal to 1 second. So velocity become 2 centimeter per second. And look at the option. The second option is 2 centimeter per second. The question number 22 says a string has linear mass density 100 gram per meter and under tension of 90 Newton. A sinusoidal wave is sent with frequency of 50.5 Hz and the amplitude of 1 centimeter along the string. At what average rate does the wave transport the energy? And dear student, the average energy transported by the wave is 1 by 2, the mu, that's linear mass density, into omega square a square into the wave speed. Now omega we can find omega is equal to 2 pi into n and n is equal to 50.5. So this will be 100 radian per second. And what is the wave velocity? That is equal to t divided by nu root. And the tension is given 90 Newton and mass per unit length is given 0.1. So this comes to be 30 the meter per second, the wave velocity. So we'll pick up the parameter and fill here 1 by 2. The mu is given 0.1 and omega is equal to 100 square. Amplitude is given 1 centimeter and the wave velocity is 30. When you fill up, solve it, you get the answer 1.5 watt. Therefore, the correct option is the second answer. Let's move to the next question. The equation of three transfer waves are given as y1 is 2 sine of 2t minus 4x and y2 is sine of 3x minus 4t and y3 is 2 sine of 3x minus 3t. If the speeds of y1, y2, y3 are v1, v2 and v3 respectively, then select the correct option. Now look at the first equation. Y is equal to 2 sine of, this is omega t minus kx. And what is the velocity? Velocity is omega divided by k. The omega is 2 and k is 4. So this is 1 by 2. And look at the second one, the velocity. In this case, omega is 4 and k is 3. So velocity becomes 4 by 3. And what would the v3? V3, this is kx minus omega t. So this is 3 divided by 3, 1. Now the highest is this one. So v2 is greater than v3 is greater than v1. Therefore, the correct option is the answer number 1. The question number 24 is three sound waves of equal amplitude have frequency 300 Hz, 301 Hz and 303 Hz. They superimpose to give the beats, the number of beats produced per second. We take the two sources 300 Hz and 301 Hz, 300 Hz and 301 Hz. The beat frequency will be 1. That means 1 beat will be heard per second. So at say t is equal to 0 second, you hear the sound. Then at t is equal to 1 second, you'll hear a new loud sound. And for 300 Hz and 303 Hz, 3 beats will be heard per second at regular interval. At t is equal to 0, then t is equal to at 0.333 seconds. Next will be at t is equal to 0.666 second, and next will be at t 1.00 second. And the third case, when 301 and 303 Hz are overlapping, then 2 beats are heard. So that means the loud sound will be heard at 0.5 second interval. And look at this one. And the maxima occurs first, and let's just start from 0 first time at this one, then at this one, then at this, and finally common at 1.00. So 4 time loud sounds are heard in 1 second. Therefore, the number of the beats heard per second are 4. The correct option is the fourth option. The two waves are represented as y1 is equal to a sine of kx plus vt and y2 is equal to a cos of kx plus vt plus 2, where x is in meter and t is in second. The phase difference between them. Now, dear student, the first y1 is given equal to a sine of kx plus vt and y2 is given equal to a cos of kx plus vt plus 2. This can be changed to sine a sine of k x plus vt plus 2 and plus pi by 2. Look at the phase difference. The phase difference between these two is equal to, that is equal to k into 2 plus pi by 2. As given k is equal to pi, so I fill k is equal to pi and plus pi by 2. So this becomes 2 pi plus pi by 2, which is equal to 5 pi by 2. Therefore, the phase difference is 5 pi by 2 radian. Therefore, correct answer is the option number 3 to this question.